In this video, we're going to talk about how AI decides by asking nearby friends. That is, we are going to talk about the very interesting algorithm, the KNN algorithm. And this particular video is brought to you by my YouTube channel, AI Nexus. Please do subscribe to my channel. I'm Dr. TV Geeta. So, what is KNN? It is the simplest and most powerful algorithm. It is a supervised learning algorithm and it is used both for classification and regression. It is one of the most simple and, as already said, widely used algorithm, especially for classification. And the concept is similar points tend to be near each other. So why is it called K nearest neighbors? K because the number of nearest neighbors that are taken into account. Nearest because you are finding a distance between 2 points which is nearer and all that. So using some distance, which is here we are saying Euclidean, we'll discuss this later. And neighbors is the closely labeled data points in the training data set. And why is it supervised? It learns from labeled training data, where the training data contains features, that inputs and the class labels. And it is also called a lazy learning algorithm because no model is created during training. Training is just the storing of data. Learning happens only when a prediction is required. It postpones all computation until the new data point needs to be classified. Because the actual computation is delayed until prediction, KNN is called a lazy learner. Now let's take an example and explain this step by step. Let us assume we are taking k is equal to 3. So you've got labeled samples, apples, mangoes, and we've got a new fruit. Here it's a star, a blue star. So we take the distance between these data points and we take the nearest 3. So the nearest 3, 2 are apple and 1 is mango. When you take majority, obviously the new fruit is apple. So let's take this in the form of an algorithm. So input is a training data set and of course the new data point, and you should also know the value of k. So the first point is choosing the value of k. Then you compute distance from the new point to all training samples and then you sort the distances. And then you select the k nearest neighbors and you count the class labels. Whichever has a majority class, that is the predicted class which comes as output. So now the question is, how do you choose the k value? The value of k greatly affects the performance. So if it is very small, for example, k is equal to 1, advantage is it captures the local patterns and is flexible, but it is sensitive to noise, it has high variance, and it is an overfitting. Large K advantages stable prediction, less affected by noise, but disadvantages may ignore local structure and there is underfitting. So you obviously have to choose a correct value of K, for which the rule of thumb is K is approximately equal to the square root of n, where n is the number of training samples considered. So you have to always choose an odd value because otherwise you can't find out the majority. Now let's talk a little more in detail about distance measures because that's what KNN use to measure similarity. So the most commonly used is the Euclidean distance. So the distance between 2 points A and B is nothing but the square root of, here we have taken a 2-dimension. So it is the point A is 2, 3 and point B is 5, 7, and this is the calculation for that. Another is a Manhattan distance, which is normally used when you don't want to do too much of computation. So here we just do not take square root and all that. So we just do a minusing of the 2. Then you have the Minkowski distance. This is taking 1 by p, where if p is, it is more flexible. If p is equal to 1, it is Manhattan distance. Euclidean distance, we took the square. So that is p equal to 2. Then you have something called Hamming distance, which is used for categorical data. So suppose you have the such a data, you count the number of positions where values differ. So in this, the values differ in 2 points, isn't it? So the Hamming distance is 2, different at position 2 and 4. So these are the methods that are used to find the distance between two data points in KNN. But most commonly used is Euclidean distance. Then you can also talk about time complexity, which is very important when you talk about any algorithm that you want to use. So since KNN stores the training data without doing any computation or building a model, the training complexity is of the order of 1. Now, prediction probability is, first you have to do a distance calculation. If there are n number of training samples and d is the number of features, then the distance calculation is of the order of nd. Sorting will be of the order of n log n because you have to sort the distances. So overall prediction is nd plus n log n. So this is the prediction. Of course, we already know that n is the number of training samples and d is the number of features. Then let's look at the advantages, disadvantages and applications. Advantage, it is very simple to understand. It is easy to implement. There is nothing called the training phase. Works well with small database sets. Can model even complex decision boundaries. Suitable for also multi-class classification. However, the disadvantage is it is slow for large data set. There is a high memory requirement and it is sensitive to irrelevant features, and it is also sensitive to feature scaling. Okay, performance decreases with high dimensional data where the number of features are very high. This is typically called the curse of dimensionality. Applications, there are a lot of applications like handwritten digit recognition, face recognition, medical diagnosis, email spam detection, recommendation system, image classification, credit risk analysis, customer segmentation. In fact, since KNN is simple and powerful, it has been used in a lot of early applications. Everything they try to use. So you have to have the proper data and you have to choose the correct features. Then your KNN will work wonderfully. Thank you.